The adult population of a town is 25,000 at the end of year 1. A model predicts that the adult population of the town will increase by 3% each year, forming a geometric sequence. We need to show that the predicted adult population at the end of year 2 is 25,750. So if it's 25,000 at the end of year 1 and that's going to increase by 3%, I just need to times that by 1.03, and that does in fact give me the 25,750. So that is part A. Part B, write down the common ratio of the geometric series. Well, the common ratio is the 1.03. That's what I'm going to be multiplying by each time to increase something by 3%. The model predicts that in year n, will be the first year in which the adult population of the town exceeds 40,000. And I need to show that this statement here is correct. So let's take our nth term here. Let's figure that out, and then we can find out when it's going to be greater than 40,000. So we know our first term was 25,000. Our common ratio is 1.03. Now remember, the general nth term formula for a geometric series is AR to the n minus 1. So in this case, it's going to be 25,000 times 1.03 to the power n minus 1. And we want to know, when is that going to exceed, when is that going to be greater than 40,000? So first thing I'm going to do, I'm going to divide both sides by 25,000. So 40,000 divided by 25,000 is going to give me 1.6. I can then take logarithms of both sides. So I'll take log on the left-hand side and I'll take log on the right-hand side. Just log base 10 here, just so it matches up with what I'm needing to show here. And the good thing about that is I can then use the laws of logarithms to take this n minus 1 power and move it to the front here. So that's going to give me n minus 1 times log 1.03 is greater than log 1.6. And that's what we needed to show. For part D, find the value of n. Well, I can divide both sides by log 1.03. We should be careful at this stage because this isn't an equality. I do need to be sure that I've not just divided by a negative. But thankfully log 1.03 is a positive number. That's not negative, so I don't need to worry too much about that, but I should consider it. Then all I'm going to do is add, so let me type that into my calculator. So log 1.6 divided by log 1.03. So that's going to give me that n minus 1 has to be greater than 15.9. So therefore n has to be, just adding the 1 to both sides, n has to be greater than 16.9. So this is going to be in the 17th year. $16 wouldn't be enough. It has to be in the 17th year. We're then told that at the end of each year, each member of the adult population will give £1 to a charity fund. Assuming the population model, find the total amount that will be given to the charity fund for the first 10 years from the end of year 1 to the end of year 10, giving you an answer to the nearest 1,000. So basically each person gives £1. So that means in the first year, the town raises £25,000 because there's 25,000 of them all giving £1. In the second year, they all again give £1, and there's 25,750 of them. So that's how much money they make in the second year, and so on. So this is still the same sequence. This is still the same sequence with first term 25,000 and the common ratio of 1.03. Just we want the sum, because we want the total amount, in 10 years. So let's use our sum formula, that Sn equals A times 1 minus R to the power n, divided by 1 minus R, which will give us 25,000 times 1 minus 1.03 to the power 10, divided by 1 minus 1.03, which to the nearest £1,000 is £287,000.